אז שלום לכולם. שמי דוד קונופניקי, אני מנהל קבוצת Language and Retrieval ב-IBM Research AI. אני אדבר היום על עבודה בתחום... I should speak English, right? Everybody understood. It's okay. So my name is David Konopnicki, and I manage the group of Language and Retrieval in IBM Research AI. I will talk today about work that we did in the domain of summarization, text summarization, in the past few years. And I want to show how we took this work from work in the lab, because we are a research lab, to the real world. Now, summarization is a task that is quite hard in AI, because it is hard for humans and it's highly cognitive, so it's more so for computers. So let's assume that you are given a set of documents, let's say news articles about some companies, and you are given a task. I want you to summarize all the information that is in those documents that is related, let's say, to finance. Right? So you are given documents and you are given a topic, and you need to summarize that. So I assume that as humans, what you would do is, take those documents, highlight the sentences that are relevant to the topic in those documents, and then you would consolidate the information that appears in the different documents, and then maybe do some rewriting, consolidate the information, do reordering, etc., in order to create a summary. So you see that it's a complex task. So if we look at what exists in this, how to decompose the possibilities that we have here, we have, first of all, generic opposed to query-focused summarization. Generic summarization means that I give you a document and I tell you, summarize what is there. If I do query-focused summarization, what I mean is that not only I have to summarize, but I have to summarize only the information that is related to some topic that is given. Now, we have extractive versus abstractive summarization. Extractive summarization means that I just take existing sentences from the document. I select sentences, I highlight sentences, right? When I do abstractive summarization, I create new sentences. Now, you understand that, for computer, extractive summarization is easier than abstractive summarization because you don't have to write new text. And you also, I will say a word about our experiments in abstractive summarization, but again, as people that have experience in AI, you certainly understand that abstractive summarization is done usually using deep learning, right? So it's newer techniques than what is being used for extractive summarization. And the problem with, generating new sentences is that computers are not too good at it right now, and they create sentences that are non-grammatical, that make no sense, that change the meaning of the text, etc. So it's still, even in state of the art, it's still, problematic. But I'll say a word about that. Now, in terms of, the methods that are being used for summarization, we certainly have unsupervised versus supervised methods, where the problem in summarization with supervision is that it's very expensive to create examples, right? As opposed to, I don't know, tagging pictures, right? It costs a lot of money to create a data set of summarization. And now, I already talked about that. We have multi-document versus single-document summarization. Now, we started by focusing on unsupervised learning. Why? Because, as I said, labeling is very expensive for summarization. Also, lots of times, so we do that in the industry, right? And most of the time, we go to customers and they are not able to provide us with examples of summaries of the documents that they would like to summarize. And if we are talking, we want to use deep learning methods, we would need, tens of thousands of examples, right? So it's not viable. So we decided to go to unsupervised type of summarization. We also want to be able to move from different domains. usually in the academics in this domain, people summarize just news. But in the industry, people want to summarize reports, they want to summarize presentations. So as you know, our methods are not very portable from domain to domain. And in the end, privacy, yeah, when you work in the industry, you have privacy problems. Some customers do not want to give you examples of the documents, or too many examples of the documents. Okay, so now, on which data can we use if we want to train a system, or if we want just to evaluate a system? So a very common task that exists in the domain is called DUC. It was a contest from 2005 and to 2007. And the task is that they give you something like 20 news articles, and they give you a task. They give you a topic. So here you see the topic: John F. Kennedy Jr. dies in a plane crash. Write an account of the sequence of events involving the Kennedy family during and following the plane crash, etc., etc. So you see that the topic is very wordy, right? It's not very common. And you need to create a 250 summary based on this set of 20 articles. Now, in order you are given ground truth. Ground truth is 4 human expert redacted summaries. Okay, so you have those examples, and so those examples are abstractive, and you have to compare the performance of the computer summary to those 4 examples, and you do an average of the results. Another very, very common used dataset in the last years is called the CNN Daily Mail dataset. What is nice there is that, you see here is an example from the Daily Mail, and at the top of the article, they publish a set of highlights. And those highlights are considered to be, a summary of the article. It's not really a summary, right? It's a set of highlights, but for all purposes, we consider it as a summary. Same thing from lots of articles from CNN. And in this data set, you have hundreds of thousands of examples. And on this data set, you can train a deep learning network. So currently, if you go to an NLP conference, all the articles almost on summarization will use this data set. And there are very good results already on this data set. But here, you see also a problem is that it's not only highlights, is that you have just one example of a summary per article. Other examples, there is DUC 2002. It was another context. An interesting one is called SciSum. It's about the task that is very interesting to us of summarizing scientific articles. And the idea that is very nice here is that when you summarize scientific articles, you can use the articles that reference the articles that you want to summarize. And when you have a reference, you usually have one sentence that describes the work in the target article, and you can use all those sentences, in order to generate a summary. So it is a very interesting data set. Okay. One important question is, how do we measure quality? So I said that we want to compare, the computer-generated summary with human-created summaries. And in order to do that, there is a measure that is called Rouge. And what Rouge does is that it compares the number of n-grams in the computer-generated summary and the human-generated summaries. Okay, so it can be unigrams, it can be bigrams, sequences of 2 words, sequences of 3 words. So you will have all kinds of such short sequences that should be common. And based on those, we compute the recall and the precision, right? Number, for example, the number of overlapping n-grams between the two, etc., and all those statistics that are very common to our domain. And what you understand what's the problem with that. The problem is that those measures do not say anything about the textual quality of what is generated. It just counts words. right? And it's a big problem. It's a big problem because when you use this type of measure in order to evaluate the quality of an algorithm, and you train, for example, some reinforcement learning algorithm to use Rouge, then it will generate summaries with the right words, but not necessarily in the right order. And that's a problem for humans that are going to read those summaries. Right? So, and that's very interesting. When you start working in this field, you don't understand why people publish articles in the domain, but never in the article publish examples of the summaries that have been generated. And when you start working, you understand why people don't publish the examples. Because there are, measures of readability. People have been working on that in the domain for quite a time, about structure and coherence, grammaticality, non-redundancy, etc., etc. There are measures, but just people don't use them. And you won't see a lot of articles using them. Sure, the advantage of using extractive summarization as opposed to abstractive is that at least each one of your sentences is understandable. Sometimes it's difficult to understand it out of the context, but still. Okay, so how do you summarize? So let's say that what we are doing right now is that we want to do extractive summarization. So, and let's consider that we have one article. What we are going to do is that we are going to look at each one of the sentences first. And what we are going to do is that we want to represent those sentences in a common way, right? It can be a bag of words. It can be, you can use BERT to create a vector, an embedding vector. You can use LDA, to represent each one of the sentences and as a set of topics. So you can use whatever. There are lots of models out there to represent each one of the sentences. The next step is to assign a score to each one of the sentences, and here also. There are lots of models in order to create scores for sentences. This is where you would apply supervision, right? Supervision will let you train, for example, a network, given a representation of your sentence, to generate, the importance of this sentence, sometimes given a topic. The last step, the summarization step, means that what you are going to do is that now that you have all your sentences of your article, sometimes given a topic, and you have a score for each one of the sentences, then you can do some optimization to select a subset of those sentences. And, you can take the n best ones, or you can use all kinds of greedy algorithms, or algorithms that, that do some global optimization, but, there is a family of algorithms to do that. So these are the three steps that all algorithms that do extractive summarization use: creating representations, then scoring, and then selecting a subset. Now, how do we do that in our system? Our system is called Summit. So what we do there is something like that. So we are given, actually, in our case, we summarize results of a search engine. So the system first retrieve some articles. We extract the sentences from those articles, and then we use an optimization algorithm, which is called the cross-entropy method, in order to select a subset of the phrases, of the sentences from the article that are optimal in some sense. And I will explain in a minute how we do that. So let's assume, so the cross-entropy method, I don't know how much people are familiar with it, but it's quite used in the domain of reinforcement learning. What you do is that you learn a policy of selection of sentences. How do you do that? Let's assume that we have the capability to, given a summary, to create a score that tells us how good is this summary, okay? What we do now, we have our articles, we have selected a starting set of sentences that are on the topic. Let's say we begin with 1,000 sentences. What we are going to do is that we are going to generate now random summaries, okay? where each sentence has, half a chance to be selected to be in a summary or not. We generate 100 of such random summaries, and to each of those summaries, we give a score. And then we rank those summaries by this score, and we take the top, let's say, 50 ones. Okay, we have now top 50 summaries that have been generated at random. We take the sentences that appear in those summaries, and we shift a little bit the probability that those sentences will be selected in the next round of optimization. And again, we generate, summaries randomly. Okay, this is how the cross-entropy method works, right? It's a Monte Carlo method. It's a stochastic method. And what happens, it's a bit surprising, but very quickly, the system converges, and it learns how to generate good summaries for those sentences, okay? And so this way, this is how the system works, and this way we are able, given a topic, to generate a set of, given a topic and a set of documents, we are able to generate summaries. Okay, so this is just an example of the results in the DUC 2007 benchmarks. As you can see, there are both unsupervised and supervised method. What is interesting is that, you see in Summit 2018, we are able to get results that are even as good as, a lot of supervised methods. Let's say in the last few months, using BERT, people have been, getting results that are better than that. And we are also working on such a system, but this was the result, at the beginning of the year. Now, when we talk about this is for extractive summarization. When we talk about abstractive summarization, what abstractive summarization does is that it's going to use neural networks to, getting a text as input and selecting words or changing words in the output, using the same type of neural networks that are used for translation, right? Sequence-to-sequence networks that will map a text as entry to a text as output. So it's pretty typical. The work that we have been doing there is deciding, being able to decide, given a sentence, whether we want to extract it as is from the text or whether we want to abstract it. So to change the text that appears in the sentence, sometimes, for example, to compress the content of a particular sentence. So here, in this network that you see here, it's a very high-level view. We have from one side an extractor. This is a network that learns to extract sentences. And then we have another network that is an abstractor, right? A typical encoder-decoder network. And given a piece of text, the abstractor selects sentences and sends the sentences that have been selected to the abstractor, and the abstractor, is going to compress or to modify the sentences that are being extracted. And then the top network, the hybrid network that we have on the top, what it's going to do is that it's going to decide whether, this sentence, we want to put it in the summary as is, or whether we want to use the abstracted version. Okay? I will give you an example so it will be clearer. So here we have an article that is a news article that we want to summarize. I don't show the source here, it's not very important. What is important, you see here at the top there is the editor's automatic summary. So the first sentence is a sentence that has been extracted as is from the source article. It says, what was supposed to be a fantasy sports car ride at Walt Disney World Speedway turned deadly when a Lamborghini crashed into a guardrail. Okay, so this sentence, the network decided that it's good enough to put it as is in the summary. For the second sentence has been abstracted. So the source sentence was here, A, you see? The crash took place Sunday at the exotic driving experience, which bills itself as a chance to drive your dream car on a racetrack. This is a source sentence. And then the network was able to abstract this sentence to the crash took place Sunday at the exotic driving experience. Okay? So, for example, it removed some part, that was redundant as opposed to the first, as compared to the first sentence. Same thing for the next one, right? The original sentence says, the Lamborghini passenger, 36 years old Gary Terry of Davenport, Florida, died at the scene, Florida Highway Patrol said. And it just abstracted that to the Lamborghini passengers, Gary Terry died at the scene. Oh, it's quite nice, right? The abstraction works quite well. By the way, there is another sentence that the network decided to remove at all. Right? It was extracted, but the hybrid network decided to remove it. So it gives nice results on news data, but the problem, as always with neural networks, is that it's not very portable across domains. And second, it generates text, word by word. So there is always the fear that when it generates new text, it's going to create something that whose signification is different from the sentences from the original text. And we found a very interesting case. So when I was preparing a talk about the system, I was playing with it and reading summaries, and I looked at one of the summaries, and it was about something in the news about police and something like that. And one of the sentences of the summary was saying, the police killed the guy by so and so. I was very surprised because I did not remember that the source article was saying something like that. And actually, when I checked the source article did not talk at all about police killing somebody. Okay? It just, the network statistically learned that sometimes the police kills people. And, it was generated. And so you understand why this type of system are still in the labs and not in production. So what we're working on is actually putting the system, so the extractive system, into production. With customer data. We have this demo where you see that you can, you enter at the top a query, and then you have a summary of, the different articles on this subject. And sometimes the sentences that are extracted are complicated to read. So when you click on a sentence, you can see it in its context. You can see also the source article with the results that are highlighted. But our biggest project right now is applying this technology to the domain of scientific article summarization. So as Oren Etzioni said in his talk, there is currently a big problem, keeping up with scientific articles. And what we decided to do is to create a system that is able to summarize scientific articles and give that for easy consumption of researchers. So we have created the system that runs right now on all the articles from arXiv and ACL. We have an ingestion pipeline that analyzes the PDF, and analyzing PDF is a word in itself. And here you see an example of the system. We hope to make it public in the coming months. You can answer a search term at the top. Here you have an example of a result card that we present for each one of the articles, where you have each one of the sections. You can click on each section, and for each section you will have a summary. And also what we do is that we select tables and pick figures from the article, and we try to map the right figure and table to each one of the sections. And we have started using it internally. It makes our work as researcher much easier. And as I said, we hope to make that public in the coming months. So to summarize, I think summarization is a very, very interesting task in the domain of NLP because you have both sides, right? From one side, you need to understand what the text is about and create representations of the text. On the other hand, you have also all the aspects of natural language generation. So generating summaries is extractive and abstractive. And you see here, much more advanced features that you can add to such a system. How do you deal with all the multimedia that is associated with the text, the pictures, the figures, the tables, etc. So great domain to work on. Thank you.